So this is going to be a quick little course on how to do ray diagrams to find images in convex mirrors. So I'm going to draw myself a principal axis. This is freehand. You guys would be doing this by ruler. So the principal axis is there. If I'm going to put my object on the left, then my mirror is going to be like this on the right, something like that. Let's say that the focus is here, and that means that the center of curvature would be right there. And then I'm going to switch to red for my beams. So this would be the setup. You could have it the other way as well, and I'll show you that too. So beam 1, you draw it parallel to the principal axis, comes in like so, and it reflects in line with F. And I don't know how good I'm going to be able to freehand this, but it's going to go out like that so that if I were to extend back that reflected ray, it would appear as if it was coming from F. Now the next beam is going to be even tougher for me because I'm going to have to direct it at F, but of course it doesn't go through the mirror. It does not go through the mirror. It bounces off the mirror. A beam that's pointed at F will reflect parallel to the principal axis, like so. And if we dot it back, you'll find an intersection point somewhere right around there. Of course, this should look much better if you are using a ruler. Matter of fact, I'm just going to back up one and just make it in red here. So my image would be right there. Just don't forget that it's the two reflected rays you dot back. You dot back this one, and you dot back this one right here. The incident rays you do nothing with other than it does guide you. You know, one parallel to the principal axis is going to reflect in line with F, and the one pointed at F will reflect parallel to the principal axis, just like in your notes. Now, the exact same thing it doesn't change any of these rules if you're just to put your object over on this side, and then the convex mirror would look something like this. Again, we can say, I don't know, I'll just make the F 3 squares away, and I'll make C then 6 squares away. The same sort of rules will apply. I didn't like the way that red looked though, so it's going to come in like this, and then it's going to reflect as if it came from F. Again, with the ruler, you can set this up a lot neater. And then my second beam is going to, I'm just going to try and change the color here. My second beam is going to go towards F, and it will reflect parallel to the principal axis. The one that you dot back is that parallel reflected ray. Oops, let's go back there. And my image will be right here where those two beams meet. The bottom of the image is always right along the principal axis, just like usual. So that's coming at it from either way. That's how you're going to find an image. The image characteristics here, salt. Anytime you're using a convex or diverging mirror, they mean the same thing. You're going to get a smaller, upright, in the mirror, or you could say it's behind the mirror. You could also say that it's between F and the mirror, since F is inside the mirror for this type of mirror, but usually most students have just been saying it's inside the mirror or behind the mirror. And then the type is virtual. The reason it's virtual is because it appears inside the mirror, and you could also say that it's virtual because the real rays don't meet. The real rays are here and here, and the beams that met were these extensions inside the mirror that we had to find. So there's a couple of ways that you can define what a virtual image is. And this is the case anytime you're using a convex mirror. These are going to be the image characteristics. It doesn't change depending on the position of the object, like in a concave mirror. This mirror, you could say, is a little bit more boring, as you always get the same thing. All right, that's about all I have for now. Good luck.